In this video, you'll learn how to complete Part 2 of the stock market project. Last time, in Part 1, we completed steps 1 through 5 and answered questions 1 through 5 in the handout. You should have already completed the first 5 columns and then also completed your scatter plot and a residual plot. For the purposes of Part 2, I went ahead and copied and pasted them into a different tab so that nothing was accidentally done to them. But for the next couple steps, you're going to want to have a copy of your original scatter plot handy on the page that you're working on. We're going to start today with step 6, which has you create a new column in column F with a transformation on the Y values. I recommend that you go through the entire ladder of powers to see which one makes your residual plot most straight. So I'm going to start with the first power, which is the squared power. So I'm going to label my column Y squared. And then I'm going to perform the transformation and square each of my Y values. We could do this by hand, but again, Excel will do this for you. So I'm going to type in equals. And then my Y value, in this case, is the stock price, which is in cell C2. So I'll click on it so that it highlights it and it turns blue. And then we want to square it. So I'm just going to do times itself again, times C2. Now when I hit enter, I have my squared value, and I can wait until I find the black cross in the corner and drag it all the way down. And so now it has each cell multiplying it by itself or squaring it. So let's see how this transformation did and see if it made my scatter plot any straighter. I'm going to go ahead and highlight my X values, which is the year since, in this case 1986. And then I want to hit the control key and highlight column F, which is my squared Y values. Now I'm going to insert scatter plot, and here we have my Y squared transformation. Now personally, I don't think this helped at all. I think that it only made this outlier look more extreme and definitely didn't make it any more straight. So we're going to go back down the other way on our ladder of powers. So the one step is just the raw data with no change at all, which we've already seen and we've already decided it is not linear. So I'm going to go to the next step, which is the half step, or the square root of the Y. So I'm going to label this new column, square root of Y. We could replace column F, but I found it easiest to just keep each of your transformations in a new column in case you need to go back and look at something later. So I just went ahead and kept it, but it's up to you. Now again, we could go by hand, use a calculator, and type in the square root of each of our Y values, or Excel will do it for you. I hit equal, and then when I start typing in SQ, it pulls this up, and we have SQRT, which it says is the square root of the number. So I'm going to type in SQRT, and then put parentheses. I want the square root of what's in cell C2, or my first stock price. Don't forget to close your parentheses, and then when I hit enter, I have my square root value. Again, find the black cross, drag and drop all the way down to fill out the rest of your column. So now we can again compare this to our original by inserting a new scatter plot, just like I did last time. So this third one, the square root of Y, maybe looks slightly more linear. Maybe this outlier looks a little bit less extreme, but it's definitely still not straight. So what I recommend is that you continue through the ladder of powers until you've completed the entire thing. I'm going to pause the video now and complete the ladder of powers. I've now gone through the entire ladder of powers and done my transformations on Y 5 different times. I left each different transformation in its own column in columns F, G, H, I, and J. And I've decided that the log of the transformation makes the most sense for my data. So I'm going to go ahead and keep everything still here, but I'm going to delete out, just for now, because I can always come back to it, the scatter plots that I'm not going to use. So what I started realizing is that this part, the upper half of my graph, looks linear, but there's still this cluster of outliers down here, so I thought I needed to investigate why. When I hover over this first point that's the low part of the outliers here, it is point 23. When I go and look at point 23, I see that that was the year 2009, which makes sense that there was a huge drop starting in 2009 right after the financial crisis. So I decided that I'm going to go ahead and break up my data into two subsets, before and after the financial crisis, because that's the kind of thing that you could explain to readers and tell them that you have two different linear models, one for before the financial crisis and one for after. So all I need to do is drag up this highlighted part up until number 22, so I don't include those other values here. So now we have a much more linear model. This looks much straighter, and we'll see what happens in the residuals here in just a minute. So now we are on to step 7, and we want to create a linear model. So I'm going to go to the plus sign on my graph, and I want a trend line. So now I'm going to go to more options, just like last time, just with our trend line last time, and I want to display the equation and r squared on the chart. We have now completed step 7. We have our new transformation scatter plot, and for the sake of formatting, I just went ahead and made my title a little bit bigger and changed my axes so that it's just a little bit more clear for us. And we have our new linear model here as well. So by now you should have answered questions 6, 7, and 8, and we are on to step 8. So in step 8, we're going to create a column for the predictions for our new model. So just like what we did in column D, we are going to have our new predicted price. And just like last time in the new predicted price column, we are going to let Excel do the work for us. So I'm going to type in equals and then our slope. So 0.0119 times our x value, which is still our year cents, plus my y-intercept here, which in this case is 1.5585. Now I can drag and drop all the way down. So this time, though, I will say, I only went to year 22, so I'm going to go ahead and not include the rest of these values. So I am stopping here, in this case, in 2008. So just like last time, our predicted price is setting us up for the residual plot. So our next column, we're going to go ahead and set up our residual plot for our data. And I went ahead and labeled it new just to be clear. So our residual plot is always our data minus our model. And in this case, we need to have our data, which is actually the log of our data, minus the predicted price from our log model. So we're going to do equals log of our data minus the predicted log value. And again, we can drag and drop down. So now we are ready to go ahead and finish up this last part of step 8 and create our residuals plot. So I want my years since 1986. I'm only going down to 2008. I'll hit Control and then highlight our residual values. Now I can make our residual plot, and we are done with step 8, and you can go ahead and answer question 9. We are now in our last few steps, and you are almost done. We already let Excel do the work for us, and we already have our r squared, but in step 9 you do need to calculate your r and answer questions 10, 11, and then you can move on to step 10 and answer questions 12 and 13. Once you've completed through questions 13, you are on to our last graph of this activity. So we are going to, in step 11, use Excel to fit a nonlinear model to our original data. Now, remember, for the purposes of our class, we aren't really talking about nonlinear models, but we want to explore them a little bit here with Excel. So we are going to go back to creating a original scatter plot. Now, I'm not going to mess with the one that I already have, so I'm just going to go ahead and make a new scatter plot for my original X and my original Y. Now, this time though, when I go to trend line, I'm going to go to more trend line options and see if I can fit a non-linear trend line. So this one doesn't look perfect. If, when you click this, if you get this same pop-up menu that I did, you might need to go back and change your X values so that you don't have any zeros. So my first year is 0. I might want to change that so that it's years since 1985, so that my first X value is 1 instead of 0. But I'll come back to that if I can't find another model that works. Now, when I go to this again, It's looking like polynomial worked pretty well for my model in this case. Again, you can have it display the equation on your chart, and you can go ahead and answer questions 14, 15, and 16. And once you've completed this price with your nonlinear model, then you can answer question 17. Please make sure by the end of this project that you have all questions, numbers 1 through 17, answered to the best of your abilities with complete sentences. If you would rather type up each question, that is fine with me. I also would like each of your graphs printed individually. Full page is preferable than to having it with a background of your table or whatever, or having a small one. I would love a full page of each of your graphs that you've created. So that would be your original data, your original residual plot, your transformed scatter plot, your transformed residual plot, and then your exponential model. So that's 5 graphs total. And then I would like to also have a printout of your data table just so I can see it. This all needs to be turned in to me together with the questions. If you have any questions, feel free to let me know.